Problem 7 is asking us to list all the zeros for some various polynomial functions. This first one is second degree. This third one is third degree, so we have to find 3 zeros. Here we have fourth degree, so we have to find 4 zeros. And then on this last one, second degree. Now, a couple of things about these. It says if 0 is complex, if the 0 is complex, then we need to write it in standard form. All the zeros may be used by using factoring. That's what we'll try first. Extracting square roots, if that's appropriate. Quadratic formula. No decimal approximations. This needs to be all exact answers. So let's just recall what it means to find a zero. We'll start with this first problem. 6x squared. Let me clean that up a little bit. Let's go with this color. 6x squared plus 13x minus 5, and we're finding zeros, so set it equal to 0 and solve for x. Now, this has a leading coefficient more than 1, not 1, so we're going to look for factors of 6 times negative 5 or negative 30 that add up to be 13. Positive 13. 15, negative 15, and 2 seem to work. So our first step, when this leading coefficient is not 1, is just bring 6x down, minus 15, 6x plus 2. Now this thing doesn't actually equal 0. It's just an intermediate step. We need to look for common factors to get to the final factorization. 3 divides evenly into 6 and 15. That's 2x minus 5. 2 divides evenly into 6 and 2, so we have 3x plus 2 equals 0, and so one of the zeros if we set this equal to 0, this first factor, think just mentally, I'm just thinking, well, if I add 5 to 0 and then divide by 2, I'll get a positive 5 halves. And if I subtract 2 from 0 and then divide by 3, I get a minus 2 thirds. Those are my zeros. So I'll write them on up here. So the zeros here are 5 halves, negative 2 thirds. And you could check that by graphing it. But you wouldn't get this exact answer if you graphed it and used your calculator. Okay, the next one. We'll go with this color. So we have x cubed minus 2x equals 0. Now this is x cubed, but first step in factoring, always. Factoring is your best, easiest method if you're reasonably proficient at it. You should always look for a common factor first. And we have x squared then minus 2 equals 0. Now, to keep going, I really just, what I've got now is, it's in a factored form, it's not completely factored. But either x is equal to 0 at this point. I could say, well, x is equal to 0, or x squared minus 2 is equal to 0. Well, x squared minus 2, if I add 2 to both sides, x squared is equal to 2. And then, and so this is the extracting square roots method up here. So now I'm at a point of, oh, I've got a quadratic. I can use whatever method I want here. I'll just add 2 to both sides and extract the square roots. When I take the square root, both sides, it's plus and minus. So x is equal to plus or minus root 2. So here's a 0 here, x equals 0, or root 2, or negative root 2. Okay, now we have a 4th degree polynomial. Now, in this case, 2x to the 4th minus 24x squared is equal to 0. Look for that common factor first, and you should see that 2x squared is a common factor of both. So 2x squared times x squared minus 12x equals 0. Now, this is a double root here. You could say, well, I can divide both sides by 2 to keep working on this, but x squared is equal to 0, or x squared minus, whoops, that should just be 12. Let me erase that. All right. X squared minus 12 is equal to 0. All right, so this would be a double root, 0 times 0. So in this case, x is equal to 0 or 0. And over here, adding 12 to both sides, I get x squared is equal to 12. Well, taking a square root of each side, we did last time, we get x is equal to plus or minus root 12, and that's 2 times 6, 2 times 3, so x is equal to plus or minus 2 root 3. So my other two zeros, 2 root 3, negative 2 root 3. Okay, so the last one, we're looking, let's find a different color. So the last one, we're trying to solve this, x squared plus 2x plus 2x plus 5 equals 0. Well, factors of 5, the only factors of 5 are 1 and 5, and there's no way to get that to add up to 2. So we could do a complete the square or quadratic formula. I'm sorry, so let's do complete the square. So I'm going to back up here a little bit. I'm going to subtract 5 from both sides. And I'll have x squared plus 12x plus 2x is equal to, leave some space, is equal to negative 5. Now, to complete the square, I've got an x here. I'll take half of 2, that's 1. Square 1, that's plus 1. square 1 plus 1 here. So this is equal to negative 4. Now take a square root of each side. It's plus or minus here. This is going to be on the left, x plus 1. On the right, it's plus or minus. Now it's square root of a negative, so it's plus or minus square root of 4i. But that's x plus 1 is equal to plus or minus 2i. Or subtracting 1 from each side, x is equal to negative 1 plus or minus 2i. Negative 1 plus or minus plus 2i, which is 1, 0, negative 1 minus 2i, which is the other 0. Now, if I were using the quadratic formula on this last problem, let's just pull up quadratic formula. So taking this last problem as quadratic formula, and let's separate this off a little bit, would be the opposite of b, negative 2, plus or minus b squared, 2 squared, square root of 2 squared, which is 4, and then minus 4 times 1, which is 4, times 5, or minus 4 minus 20 over 2 times 1, 2a. This would be negative 2 plus or minus, and inside here it's negative 16. So it's plus or minus negative 4, the square root of negative 16. Let's just put that there. Let's not go too far. Over 2. Well, this is negative 2 plus or minus negative plus or minus 4 and I. We have that negative 4i over 2. That is, simplifying all this out, negative 1 plus or minus 2i. So it's the same either way. You kind of pick what you want to do. Quadratic formula is based right off of, you can kind of see how it works, kind of like quadratic formula, but it, it's each have their complexities and simplicities. Anyway, hope that helped.